Excellent. So yeah, let me extend a welcome, everyone. This is definitely a great turnout for DevNQ. It's very exciting. I'm really looking forward to the awesome stuff that we'll be doing the rest of the year as well. So, stick around. I think we'll be seeing some cool things ahead. So, in case you can't read, my name's André. And I'll be talking about functional programming. Now, what I'm going to do first is who's actually heard about functional programming? Oh, wow. Awesome. Okay. Now, who regularly uses functional programming? Oh, okay. All right. So not so many people using it. So what I really want to do is give you a little bit of an introduction about functional programming and also get you a bit excited and, to sort of give you a glimpse in what it can do. So yeah. Now, before I start, I want to take you on my journey on how I learned about functional programming. So a bit about me. Pop. All right, let's just press the button instead. So I'm a senior developer at JESI, a local Townsville startup building journey management software. A great opportunity. It's awesome seeing Townsville startups. It's really starting to grow. I develop full stack web applications. So it pretty much means to do the whole kit and caboodle, front and back, everything in between, just to give you an idea of sort of my skill set. Now, I'm originally from Townsville. Don't hold that against me, please. But a couple of years ago, I spent some time in London, and I really enjoyed it because of the dev meetups there. I learned so much. It was really great meeting other devs and bouncing ideas around. And it was during that time that I heard about this thing called functional programming. I'm like, that sounds a bit weird. Functional programming, shouldn't all programs, be functional? But yeah, this is where it really exposed it to me. So I also really want to say, I'm not an expert. I'm only still on my journey about functional programming. But like I said, I want to take you with me and hopefully give you a bit of a introduction and get you excited about it. So let's define it. What is functional programming? And honestly, this is the hardest part of functional programming. Coming up and actually getting with a good definition. So, as the name says, it's programming with functions. It's functions inside of functions, returning functions, on top of other functions, composing functions together. It's functions all the way down, a bit like turtles. And the big difference is, though, your application state is transformed through all those different functions. And that's very different to some other paradigms like object-oriented or procedural code. In procedural code, you define your variables, you sort of go, right now, iterate over this thing. In functional programming, your state is very different. It's all exposed and then transformed through your functions rather than being encapsulated. And I'll give you some examples of that. And the weird thing about this functional programming thing is it's been around for ages, like right back to the 60s, I think. And it's really getting a resurgence now with people seeing how they can do things differently in JavaScript. And that's also where I started with functional programming. So I'll be giving you some examples in JavaScript as well as Java, but the main chunk of it will be in JavaScript. And unfortunately, for the sake of understanding, I'm not going to be using cool, fancy ES 2015. I'll just be using old school JavaScript. But really, let's also break down the core of functional programming. The main chunk, what you need to have functional programming is first-class functions. So what I mean is that your functions can be values. They're supported as your top-level objects in your language. And I'll give some examples of that. You also need higher-order functions, and that simply means functions that return other functions. Pure functions, so that means your function says, all right, all the things that I need, give it to me, and I don't change anything else. I'll give some examples of that as well. And finally, immutability. So this is a data structure thing. And I'll give some examples in a second. So, first-class functions. That is where your functions are values. So, how's that look? Good. So in JavaScript, you have a function, and you say, hey, let's assign it to the value of greet. Sweet. It's first class. You can do that. In Java, for example, in Java 8, which is actually useful now, you can assign it. So you go, hey, greet, and make my lambda expression here, hello, name. It's a first-class object. It's supported by your language. And higher-order functions are functions that return other functions. So, for example, in JavaScript, we have a function called plus. And as you see, plus returns another function. And that's where the actual, logic of the addition lies. So we take the left parameter and the right one there as the closure scope, and then add the two together as the return value of the inner function. So what that would look like is you go, define a value of plus 3. And as the name would say, it means take this and plus 3. And that's exactly what it does. So if I go plus 3 on 2, I get 5. Simple concept, but really powerful in functional programming. Example in Java. So we have a function that takes an integer, returns a function of integer and behaves exactly the same way. Now, unfortunately in Java, functions have to be invoked because they're still technically classes. So you have to actually call the apply method on them. Now, pure functions. So these are functions that don't have any side effects, which means everything that you pass in is what it needs and doesn't go modifying anything else. It doesn't modify its parameters. It doesn't modify anything outside its scope. So here's a bad example. Here we have a array of words and a function that says thanks, and it just changes the index to be thanks. You invoke it, so it actually does its thing, and then it updates words. I'm like, cool. The issue is now, we're not passing thanks in. It's modifying things that we're not telling it to modify. It's impure. So a pure version would do something different. It would not modify its parameters, but return the change. So what thanks would do here is instead slice that to actually get a copy of that array, update that, and return that new array. So that way it's not modifying anything. We're just telling it what to do, and it just does that without changing anything else. So we then invoke that with the actual array, and hey, it gives us the result we want. Thanks. However, words is unchanged. A quick example in Java as well. So here we have a consumer, which is like a function that doesn't actually produce any values. And so, yeah, we say set number 2 to thanks. And as you can see, it then modifies the words. And here's the pure version. Similar sort of thing. We take our list as an input instead, get a copy of that bad boy, update it, and then return that modified. Now, as you saw there, we're taking a copy of the entire array. That is not very efficient. And so you wouldn't want to be doing that all over your application. So one of the great things about mutability is that you're changing your references as you change things along, but not necessarily the underlying data structure. So what I mean with that is your changes get added to your data structure rather than the whole copy of the data structure changing. If you think of a list of 1, 2, 3, I then go add number 4, that returns a new reference, but 1, 2, 3 is still in there as a separate reference. So there's a lot of internals happening around here, but the point is it's a lot more efficient. And as you'll see, a lot simpler. So we'll use a great immutable library from Facebook, and what we'll do is we'll define that as a list, and we go set number 2 to thanks. I go, cool. And it just does all that. It just does that nice little change. It's very efficient, a good way to go. Similarly in Java, we use a thing called Parugo, and same thing. We go, all right, take my list, replace number 2, give me a new reference to this changed list. And that's what it does. Now, any questions so far? Right, everyone's on board? Awesome. So, I've talked a bit about functional programming. Now let's actually use it. What difference does it make when we actually use this thing? Higher order functions are fancy and all, but what's the point? So, we're going to take a to-do list, a task list. And we want to create a function that takes a member, it gets all the data for that person, and then finds all the incomplete tasks for that member, returning the task with their IDs, priorities, titles, and due dates, so doing a bit of transformation, finally sorting that by due date. So that's the plan. That's what we have to do. So let's give it a go. Here's our data. Don't be too scared. Don't try and memorize that. But as you can see, it's just a collection. It says our array with objects in there, with properties of ID, complete, member, title, all those things that we need. And I'm wrapping that in a promise so that it's like an asynchronous communication, but it's a similar interface. But in this case, it's hard-coded. Who here has used promises before? Cool. All right, quick overview then. So promises are a different way in JavaScript to do asynchronous code. So normally you would do like a callback to do asynchronous code. And in promises, you instead return a value, which you can then chain together. You can also do some real other cool things, but you'll see at least the chaining part of it and how that just flattens out your code, make it a bit more readable. And so let's go through the procedural approach. So first we fetch our data. And then because we have this promise, we have a .then method on it, passing in a new function, and say, all right, go get the tasks. So we have this data thing, we just want the tasks part of that. And we'll go through this code a little bit more further up, so don't worry if you don't quite get it. We then get the tasks for that member. We say, okay, cool, let's have our results, let's have our index, initialize our index, let's make sure it's actually less than the length, just increment that bad boy. Let's now get the actual item, get the member attribute. All right, now we're actually the bit that we care about. Is this member attribute equal to the member name? Sweet. All right, now let's add it to our results, getting it again, and putting that in. So this is like very much a procedural approach using for loops. But as you can see, there's a lot of boilerplate. Look at this next chunk. I mean, if it's similar, you should be going, hang on, why is it similar? Same thing, we're going, here's our results, here's our index, let's go through that. And we're going with not task, the task is not complete. That's the chunk we actually care about. And then we add that in and return those results. So a lot of boilerplate. Same thing here when we actually now want to get the specific attributes. So we don't want the whole task, we just want the specific chunks. And what we do is here's our for loop, there's the boilerplate again. We get that task, and then when we push a new object in that matches those keys. So ID, task ID, due date, task due date, etc. Finally returning the results. And the nice thing is here, finally we sort, and we go, all right, task.sort, so we're using the array built in there. Let's do our due date minus the second due date as the comparator. So it sorts it ascending date-wise. So that's the procedural approach. What I want to show you now is the different ways we can make this a bit more functional using just a few reusable functions that, if I had to write all this over and over again, it'd be annoying. Like, why am I having to rewrite all this iteration stuff? Rather use small reusable functions that you can use all over the place. Functional programming is programming with verbs. It's using actions, and so hopefully you'll see that here. So, before, we have our function in our promise, and we say, all right, return the tasks, or get tasks. It reads a lot nicer. And get is a very simple function. It's a function, it's a higher order function, and it says, for this property, return a new function that with the object I then give you, give me that property. That's it. Nothing too complicated in the get there, but it just makes that code a lot more readable. The next chunk. So certainly during this part, guys, if you have any questions, just hand up and I'll hopefully be able to help. So the next chunk here, we actually want to filter by the member name. So we want to grab the actual member name and make sure it's equal to the value that's passed into our function. So before and after. So we go filter, where equals, so I'm equaling two things in the statement. Getting the member is equal to the actual value of member name. And certainly the biggest difference you see with this functional stuff, a lot less code, and hopefully a bit clearer. Now filter, where you can use arrays filter as built in JavaScript, really handy. Equals, again a higher order function, it takes left and right expressions, and our value then evaluates those left and right values. And finally value is just like a hard-coded thing. It's just, here's the value, give it back to me in the higher order function. So we can use it in a nice higher order way here. Here we also want to give the ones that are not complete. Reject, get, complete. So reject is the opposite of filter. We want to filter the opposite thing. So we use the filter function we defined before, but instead we go, rather than filtering it to include these things, exclude them, do the opposite. And as you can imagine, not is very straightforward. We have a predicate, which is that function that evaluates a true or false, and a value, and we go, right, evaluate it, go invoke that, but then negate it. Give me the opposite. And here we have our bit where we want to grab the individual attributes out. There's the functional version. We go, all right, next step, do a map. So that uses rave.map, we'll get to that. Picking out these attributes. So you just say, give me these strings. So map, we use array map. Who here hasn't used array map? All right, cool. So array map is transforming over an array. So if you are iterating over it, it applies the function that you pass into it to the value at that point, returning a new value and setting that value. So for example, we might have a list of 1, 2, 3. If you map that with like plus 2, like that one we had before, you would then add it to, plus 2 to that. So it'd be 3, 4, 5, So that's sort of how it works. It transforms it as it iterates through that array. That's what how map does. And then pick. So pick here is sort of constructing a new object for us in a nice programmatic way. So, right, let me ask quickly though, reduce. Who here has used reduce? Right, let me give you a quick example. So reduce is similar to map, but it has this concept of an accumulator. So a value that gets passed along every single function. So what I'll quickly do is just step through this code to hopefully clarify that a bit. So we call properties, which is our array here, ID, due date, and title. And we say, go reduce this. Our function, as you notice, takes two arguments this time, an object, or that accumulator, and the actual property. It also has its initial value. So what it does, it goes, okay, for my first time I call this function, pass me my initial value as my object. So that's what that value is there. It then has the property of ID. So we then go object, being our empty object, ID equals to our source object, which is what the underlying thing we want to grab the values from, get that property. And then the next step is it returns that. So reduce then returns that value, which then gets passed into the next function. So now our object has ID in it. It comes back around. It goes, okay, cool. Now I have this object here, which has ID and property of due date. And then it goes again, all right, now add due date from the other due date. And returns that. Boom, it passes it to the next function. So like I said, it has this, it's like a map, but with an accumulator value that gets passed around too. I would highly recommend getting very familiar with the array built-in functions in JavaScript. You can do some really awesome stuff with that. But yeah, so that's what it does. It sort of constructs this object as it goes through those keys. And then lastly, we have sorting. So in this case, we're using the array built-in sort. And we're saying, all right, let's get the due date, compare this to the first one. And in functional, we do it that way. Sort by getting the due date. So sort by is just a function version, if you will, of the actual comparator here. So we go, all right, with this function, go apply that to my first, and then apply it to my second as well. And so we can do things like that. And then get, we've talked about before. So it just goes and extracts that attribute. Now, here's the crunch point. This is how you would do things in a procedural way. Lots of boilerplate code, lots of things being happening over and over again. The bits of logic are somewhere buried in there, like with the if statements or with that. In a procedural way, in a functional way, bang. A lot less code, a lot more declarative. What is it doing? It's filtering. What's it doing now? It's sorting. You don't have to go digging through the internals to see what you're doing. It's a lot more declarative. The program does what it says. You're using verbs. They might also go, for those who are paying attention, hey, Andre, there was a lot of array functions in there. Why are we using those? Why not just use the array functions? Exactly. So this is how I would do it. I would use the data, get the actual task, just straight access it, and then apply the array filter, combine my predicate, so I use and, where I equal the member name, not complete, mapping it, picking those individual things, and then finally comparing. So very similar, just without the whole promise chain and using the actual array built-in functions. So even if this is sort of mutating as it goes, it's mutating it within the scope of that function. So we're not exposing mutated state outside the function. It's here's my value, here's the new value. Cool. Any questions so far? No? All right. Now, one question is, what is functional programming? The second question is, why should I care? It's a lot easier to test. Having pure functions means that all the values that it needs, everything that it needs, is defined up front. It's not modifying anything else, and it just returns values. So to test it, all right, throw some other values in there. Cool, does it get the results I want? Yes, test passed. So much easier to test because it's a lot more predictable. It's a black box that I actually know what's going on without it, a black box taking over the world. And a lot easier to test pure functions. Wait. It's a lot easier to read as well, being declarative. You're programming with those verbs. What does filter do? It filters. And I think that's one of the great benefits. You don't have a new reader, jumble, impl factory thing. Like, what does it actually do? I don't know. In functional programming, because those functions do that one thing in a nice way, it's a lot easier to read. It's fantastic for data transformations. So if you ever have values coming in, you need to massage it into something else, like we had in this example, where our server was giving us a lot of extra stuff in the wrong order we didn't really want. Functional programming. Think functional programming. And the great thing is you don't have to learn all the stuff of functional programming. If anything, don't even have to memorize all these slides. Use a few tools and you can go a long way. So I highly recommend, if you're using JavaScript, have a look at the map and reduce built-ins for the array and use them. Go, oh, okay, rather than iterating over this thing, constructing it, how can I use map and reduce to actually achieve the same results? And so I would say that, as well, that functional programming is great because you can take it across languages. So I gave examples there in Java, And there's heaps of other things I can do in Java, but you can apply that in JavaScript, in Python, and even functional languages like Clojure or Haskell and those sort of things. You can take these same concepts with you. Even if the language itself isn't technically a functional language, you can take those functional concepts and use them. Now, the face-off. Object-oriented versus functional programming. So a lot of us will be familiar using object-oriented programming. And I'd say object-oriented encapsulates your state change. So it'll have like a private fields, and it'll have getters and setters to mutate those, and you'll then, that's sort of how you interact with that object via its specific methods. It hides its state away internally. Oh, the order of these are wrong. It's supposed to go to that side. Anyway, whereas in functional programming, we transform that state through functions. You can see the state, you can see the object as it's being transformed through those series of functions. At any point, you go, oh, why is this not working? What values are coming through? You can go, all right, let's chuck a debug line in there. That's the wrong thing. I need to do this instead. It's a lot more transparent as your application transforms its state. Object-oriented frequently is a lot more imperative, a lot more procedural. And functional programming is a lot more declarative. So because you're using these verbs, it really is a lot clearer what you're doing. It's a lot easier to read. And considering code is read a lot more than is written, making your code easy to read is a big deal. And finally, in object-oriented, you compose your objects together. The objects talk to other objects. But in functional programming, you compose your functions. So you have functions that return other functions, you combine your functions together, you chain them together, and that's how it works. So you just take these little pieces, make bigger pieces, and by the end, you have an entire program. Now, hopefully, I've got you sort of interested in functional programming, giving you a bit of an idea, a bit of a glimpse into reading some more stuff. So this is what I recommend. Get rid of for loops. Anyone here who's worked with me knows I absolutely hate for loops. If you give me a for loop in a code review, I'm going to go no. Because frequently in a for loop, you're just defining an iteration. It's like, I want to go over this thing. That's nice. What are you actually trying to do? More often than not, you want to filter. You want to get rid of some stuff. Or you want to map. You want to transform the values inside. So get rid of for loops. Think, rather than using a for loop, at least use a for each. So again, in JavaScript, you can use this for each style. And then as you develop it, go, oh, hey, that's actually doing a map. And then straight away, you can just change that one value to map. And so it's already taking that function in. So, but I'd say that, get rid of those for loops. And even for each's, just get rid of them. Get familiar with your array and stream functions. So JavaScript has those great array built-ins, like filter, map, and reduce. Get familiar with them. Really wrap your head around how reduce works and the cool things you can do with it. In Java 8, you've got these stream functions, the stream library. It's awesome. Seriously, give it a go. It blew my mind. I'm like, wow, Java's useful now. And the nice things as well, all these little bits that I was showing you as examples, like the gets, like the sort by, there's libraries that already have that defined. You don't have to go rewriting it. Some fantastic libraries for JavaScript is like Ramda, which is world class, and lodash, which is very familiar to a lot of people. So if you've used like even jQuery and that sort of stuff, very similar style. And then I also say, use immutable persistent collections. So as you saw with the immutables, we actually take a new reference when we modify our data. Use that because it forces you to have pure functions. It forces you not to go modifying your state all over the place. If something gets modified, it gets passed along. So use those immutable persistent collections. There's some great libraries up there. I gave you two examples here for JavaScript and Java. And finally, as I said, try a bit. Give it a go. It is a journey. There's a whole bunch of things I don't even understand. Like, what the heck is a Y Combinator? What does that even do? I can't wrap my head around these things. And there's a whole bunch of functional things out there that's just far beyond it. But don't even worry about that. Don't worry about the full extent. Just learn a little bit, take these principles, learn a little bit, use it, cool. What else is there? And just keep growing your knowledge that way. Some great links. So this slide's by Scott there. I based my example of his. It's a great slide deck to go through, so I'd recommend that. Otherwise, there's some fantastic books, and these slides are up online. Slides.com, under the answer, what is functional programming? I'll also stick that on the meetup group. Awesome. Thank you, everyone. I really hope that gave you an introduction and you're excited about it. So, good.